Welcome to our presentation. Today we are going to learn about different sensors. First, we are going to see about Max 3000. This Max 3000 sensor is a compact integrated pulse oximeter heart rate sensor, which is a multifunction sensor, particularly used in wearable applications. It also uses infrared and red light to measure blood oxygen saturation level and heart rate by detecting changes in light absorption in the blood, making it ideal fitness monitoring and health tracking device. Seeing the key features of this sensor, it is an integrated sensor combine pulse oximeter and heart rate monitoring sensor in a single chip. It is a LPC device, which means low power consumption, designed for battery oriented devices. Highly accurate, it provides reliable measurements of blood oxygen level. Small form factor, it is small and compact in size, so it can be easily integrated with any embedded microcontroller systems. Flexible, it can with it can we can do flexible operations like detecting the ambient light conditions with adjustable sampling rate. It will give digital output, so by connecting the I2C communication with the microcontroller in the digital side of the microcontroller board, we can use it as a digital output device. Built-in LED drivers control the LED light source efficiently. Seeing the pin configuration, it has more number of pins when compared to other sensors, but especially VDD, which is power supply, starts from 1.8 volt to 3.3 volt, and ground pin for ground purpose, interrupt pin for interrupt purpose, serial clock and serial data for I2C communication, and A0 pin for address selection pin in I2C, and A1 pin for address selection. It is also an address selection pin for I2C, so it has 2 address selection pin for I2C, and 4 LEDs. LED 1 for anode first LED, usually in red. LED 2 anode for second LED, usually infrared, and LED 3 and LED 4 are applicable. If you want, we can use R, and it has 3 R LED, which is cathode for first LED and second LED and third LED respectively. Coming to the working, the device is powered by the voltage, and it ranges from 1.8 volt to 3.3 volt. It communicates with the microcontroller by I2C protocol, and I2C protocol which has serial data and clock pins for data transmission and clock frequency transmission. The Max 3000 activates integrated LED, infrared and red LED to emit light into the skin. By emitting the light, it reaches the blood and absorbs the various blood oxygen level and heart rate. This device uses the photodetector to measure the intensity of the light passes through the tissue. The Max 3000 process the detected signal to filter out the noise and extract the heart rate and SpO2 information. Process data is sent to the microcontroller by I2C communication. The interrupt pin can interrupt the microcontroller process when the data wants to be interrupted. The sampling rate and the LED current can be configured for different application and environment. The data can be used in fitness tracker and health monitors like applications. Coming to the application, it monitors the heart rate and blood rate As we seen, it has a pulse oximeter and a heart rate sensor. It is used in medical wearable devices, integrates into smartwatches and real-time fitness trackers, enable remote patient monitoring telemedicine applications. It tracks vital signs during sleep for sleep quality measurement. Health helps for athletes to monitor their exertion levels and recovery metrics. Integrates with a mobile app for personal health management. Seeing the communication, seeing the conclusion, the Max 3000 is a versatile compact sensor for particularly for wearable devices. So if you want to integrate it in a wearable project, we can easily integrate in a wearable project. It is a LPC device, so it only consumes low power. It gives a digital output, and so it can be easy to interface with a microcontroller without using ADC. Because of its small form factor, it can be easily integrated with any embedded systems and can be usable in health monitoring, fitness tracking applications like that. Coming to the second sensor, the AD8232 is a low power sensor. It is also a low power device. It is single led electrocardiogram sensor, ECG sensor. So it is mainly used for heart rate measurement purpose. It amplifies and filters small electrical signals generated by the heart, enabling the accurate heart rate monitoring. It is also compact and efficient for heart monitoring devices and fitness trackers. Seeing the key features, ideal for battery operated devices, simplifies electrode placement for easy use, amplifies small ECG signals for accurate readings, reduces noise from external source, allows customization for a different application, eliminate unwanted noise and interfaces by using filters, suitable for wearable and portable devices, compatible with microcontroller with ease because of it is a digital output sensor, so it can be used without ADC, without the implementation of mentioning the ADC in microcontroller boards. Pin configuration. Coming to pin configuration, it has number of pins like RA pin for right arm input of ECG signal, LA pin for left arm input for ECG signal, RL for right leg input used as a reference ground, V plus for voltage input, ground for ground purpose, output for a digital output amplified ECG signal, yellow plus for lead off direction positive input, yellow minus for lead off direction negative input, and yellow plus and minus for negative and positive input, A ground for analog ground for improved performance. Coming to the working, it captures the ECG signal from electrode, boosters the signal strength, removes noise and interface, monitor the electrode connections, sends processed ECG data out to the out pin, suitable for portable applications. Coming to the application, for real-time heart rate tracking, it is used for real-time heart rate tracking. It is used to monitor cardiovascular performance during workouts, used in portable ECG machines, and also used in remote monitoring of patients' heart, used in clinical studies for cardiac health and for personal health monitoring systems. Seeing the conclusion, AD8232 is a versatile and efficient ECG sensor, ideal for wearable health monitoring and portable medical application. It is a low power, high accurate and affordable sensor which can be used in which can be giving a meaning to the versatile and efficient sensor, essential for real-time heart tracking and telemedicine, healthcare management, etc.